In the early hours of January 27, 2025, the seismographs on Santorini began registering something that would not stop for 45 days. By the time the swarm ended, more than 28,000 earthquakes had struck the island and the surrounding Aegean Sea. The strongest reached magnitude 5.3. Hundreds were felt by people living and working on the island. 9,000 residents, more than half of Santorini's total population of 15,500, left. Schools closed. A state of emergency was declared. And tourists arriving at Santorini's famous Caldera View hotels in the weeks that followed were welcomed to an island that had just experienced one of the most intense seismic crises in the eastern Mediterranean in decades. Most of them did not know it had happened. Studies published in Science and Nature in late 2025 and early 2026 finally revealed what had been moving beneath the Aegean. A volcanic dike, a thin sheet of magma forced into a fracture in the Earth's crust, had propagated horizontally for approximately 30 kilometers under the seafloor between Santorini and the neighboring island of Amorgos. As it moved, it cracked the rock above it in a pattern that generated those 28,000 earthquakes. And the mechanism by which it moved, described by researchers at University College London as rebounding magmatic intrusion, had never been directly imaged in real time anywhere on Earth before. The magma that caused all of this is still there. The dike it created is 30 kilometers long beneath the floor of the Aegean Sea. And 3 million tourists visit Santorini every year. To understand what the 2025 crisis was, you have to understand what Santorini actually is. Not what the travel photographs show. The whitewashed walls, the blue-domed churches, the sunset over the caldera. But what those photographs are actually depicting. Santorini is not an island with a volcano on it. Santorini is the rim of a volcano. The islands that form the Santorini group are the remaining elevated edges of a caldera from one of the most catastrophic volcanic eruptions in human history. The caldera itself is the body of water they surround. The Aegean Sea fills it, 300 to 400 meters deep in a roughly circular depression approximately 11 kilometers across. The famous view from the caldera rim, the view that has made Santorini one of the most photographed places on Earth, is the view looking down into the collapsed interior of a supervolcano. That eruption, known as the Minoan eruption, occurred approximately 1,600 years before the Common Era. It ejected more than 60 cubic kilometers of magma and rock, produced pyroclastic flows that reached the sea and generated tsunamis that struck Crete, Egypt, and the eastern Mediterranean coast. The volcanic winter it induced affected climates across the northern hemisphere. The Minoan civilization of Crete, which had flourished for centuries on the resources and trade of the Aegean, declined sharply in the decades that followed. Whether the Minoan eruption directly caused that collapse remains contested, but the connection has been proposed by scholars since the 1960s. That eruption was not the last. In 1950, a moderate eruption occurred at Nea Kameni, the small central islet. And in 1956, a moment magnitude 7.7 earthquake struck near the island of Amorgos, the same fault zone where the 2025 swarm would later begin, generating tsunami waves that reached 20 to 25 meters on Santorini's coast and killed 53 people across the region. Santorini's volcanic history is not a closed chapter. The system beneath the caldera contains active magma reservoirs, an active hydrothermal field, and a submarine volcano called Colombo, located 7 kilometers northeast of the main caldera. It is actively growing, has its own hydrothermal field on its crater floor, and its proximity to the 2025 dike's propagation path is one of the reasons scientists are studying that zone so carefully. When the 2025 swarm began, scientists initially did not know what they were looking at. The first interpretation was tectonic. The earthquakes appeared to be fault slippage, not volcanic activity. But several things did not fit that interpretation. There was no main earthquake followed by a series of decreasing aftershocks, which is the expected pattern of a tectonic sequence. Instead, the earthquakes arrived in swarms, clusters without a clear main-shock-aftershock structure, migrating progressively northeast from the Santorini caldera toward Colombo and the anadrose islet beyond it. And on February 14, 2025, the seismograph networks registered something distinct, a tremor signal, a continuous low-frequency vibration that is one of the characteristic signatures of moving magma. The island's surface, monitored by GPS and satellite radar, had begun rising slightly months earlier. In July 2024, magma had started accumulating in a shallow reservoir beneath Santorini, causing the island to lift by a few centimeters. Seismic activity had increased quietly through early January 2025. Then, between January 27th and 31st, the system underwent a distinct transition, what researchers later described as the beginning of the intrusion regime, and the swarm became something else entirely. By the time the crisis ended in mid-March 2025, scientists had begun the analysis that would produce two landmark papers. The study published in Science used machine learning relocation of approximately 25,000 earthquakes to reconstruct exactly what had moved beneath the Aegean. The study published in Nature, using ocean floor instruments mounted at Colombo, reached the same conclusion from independent data. Both found the same thing. A volcanic dike approximately 30 kilometers long had been emplaced horizontally in the Earth's crust in the 8 to 15 kilometer depth range beneath the seafloor, between Santorini and the 1956 Amorgos earthquake zone. It had moved in a pattern the UCL team described as rebounding, not a single continuous front, but a series of opening waves and pressure pulses propagating in both directions as the dike grew, similar to the oscillation of a compressed spring. Each time one section of the dike opened, the magma pressure there dropped slightly and propagated the opening forward to the next section of rock. The process repeated, in waves, for 45 days. This mechanism had been theorized, but it had never been directly imaged in action anywhere on Earth before. The 2025 Santorini crisis produced the first high-resolution, real-time dataset that confirmed dike propagation works this way. That magma doesn't just push steadily forward, but advances in pulsing, rebounding waves. The researchers described this as fundamentally changing the scientific understanding of dike intrusion and its relationship to eruption risk. Eruptions don't necessarily follow the highest pressure moment of the intrusion, because the pressure itself is oscillating. This makes the timing of an eruption harder to predict, not easier. For 3 million tourists on a caldera rim, the practical translation of that science is not reassuring. The towns of Oia, Fira, and Imerovigli, the ones with the blue domes, the cliffside hotels, the infinity pools overlooking the caldera, are built directly on the caldera rim. The Nea Kameni islet in the middle of it is a post-eruption volcanic cone still emitting geothermal heat. Every year, between approximately 3 and 4 million tourists arrive in peak season, July and August, and stand, swim, photograph, and sleep on a structure that is, in the most literal geological sense, the wall of a volcanic system that produced a catastrophe 36 centuries ago, that erupted multiple times in the intervening centuries, that produced a destructive earthquake and tsunami in 1956, and that underwent a 45-day magmatic intrusion crisis 18 months ago. How many of those tourists knew, when they booked their cliffside room, that 9,000 people had been driven from that same island 18 months before? The question is not rhetorical. It is a measurement of the information gap between what scientists have documented about this system and what the 3 million people who choose to be on its rim each summer carry in their awareness. The 1956 tsunami reached 20 to 25 meters on Santorini's coast. A major explosive eruption within or adjacent to the caldera would displace the water, filling it in a way that could generate a significant tsunami across the Aegean and toward the coasts of Greece, Turkey, Egypt, and the eastern Mediterranean. There are 3 signals that scientists are monitoring as the caldera system moves through 2026. The first is ground deformation at Nea Kameni. The GPS and satellite interferometry stations that tracked the pre-2025 inflation are still running. If the magma chamber that was inflating through 2024 is accumulating pressure again, the ground deformation signal will be the earliest indicator. As of the most recent published monitoring data, the caldera has not shown accelerated deformation since the 2025 swarm ended, but the 2025 swarm itself was preceded by a quiet period that would not have seemed unusual without the benefit of hindsight. The second is activity at Colombo. The 2025 dike propagated northeast toward Colombo's position. The submarine monitoring instruments that contributed to the nature study are still on Colombo's crater floor. If Colombo's hydrothermal or seismic activity changes, if the submarine system that shares the same broader magmatic driving force as the Santorini caldera begins to show new pressurization, it would indicate the regional magmatic system is restless again. The third is the seismicity rate in the northeast zone. The 28,000 earthquake swarm has quieted, but the dike that caused it is 30 kilometers long and still there. It is a new conduit, a pathway through the crust where magma can travel more easily than it could before January 2025. If seismicity rates in the Santorini Amorgos zone begin to rise again, it would suggest that the system is reloading toward another intrusion event, one that, depending on conditions, could propagate further than the 2025 dike did, or find a different path to the surface than the 2025 dike followed. The swarm ended, the island reopened, the tourists came back. 3 million of them, over the course of 2025, visited the caldera rim and looked down into the water that fills the place where, 36 centuries ago, the most catastrophic eruption in Mediterranean recorded history occurred. They photographed sunsets. They drank wine at cliff-edge tables. And 30 kilometers beneath the Aegean Sea floor, the new dike that the magma carved through the crust in 2025 waited, as it is still waiting now, for the next time the system decides what to do with it. Subscribe to stay ahead of what's coming.